Assalamualaikum and hello everyone. Welcome to a new video for 6.2 equilibrium constant, where this video we will discuss on how to determine the degree of dissociation. On your notes, it will be on page 11. Okay, so degree of dissociation, it means that the fraction or the percentage of molecule that dissociate. So for the degree of dissociation ni, we're concerning ourselves with our reactant lah actually. For our reactant. Okay, so here it mentioned that if the dissociation occurs completely, our alpha ni it will be equal to 1 or 100 degree, 100%. If it's incomplete, the value of alpha can be calculated as follow. Sebenarnya, okay, this is actually yang percentage dia. Ni percentage of dissociation. Okay, kalau dia degree of dissociation saja, change over initial. Where do we get our change and initial ni? It is actually based upon our ice table kita lah. So kali ni, okay, so for dissociation ni, it means that sebenarnya kalau kita tengok pada graph of concentration over time, yang ini kan, okay. So, sebenarnya kita nak tahulah, okay, so E ni is actually our reactant kan. So, as time proceed, actually the concentration ni akan berkurang kan. So, ataupun kata nama lain dia, A ni, our reactant will dissociate to form our product. So, sebenarnya for the degree of dissociation ni, kita nak tahulah berapa banyak sebenarnya percentage ataupun what is the degree of the reactant to change to our product. So, how to calculate it? Daripada sinilah. Change over initial. Okay, and then dalam case ni, whereas previously kita kalau X tu kan, kita memang kira sampai last kali. Sampai kita dapat dekat E ni kan, barulah kita boleh ignore lah which value. Tapi dekat sini, yang ini dia simple sikit. X ni, X must be a positive value. Okay, X ni sebenarnya kita punya change lah. Kenapa change ni kena jadi positive value? Sebab dalam case ni, for the degree of dissociation ataupun percentage ni, kita naklah yang change ni kita nak positive value lah. Nanti takkanlah kita dapat degree of dissociation tu negative. Macam tiba-tiba dapat negative 20%. Macam pelik lah kan? So, for our change ni, kat X ni, make sure it is a positive value. So, kat sini dia punya step dia jadi simple sikit. Tak adalah panjang sangat. Okay, so let's look for the question itself lah. So, first question, question 1 ni. 0.024 mole of N2O4 is allowed to reach equilibrium with NO2 in a 0.372 liter flask at 25 degrees Celsius. Okay, calculate the percentage of dissociation and given that Kc is equal to this value. Okay, so again, dalam case ni, remember, the information given is actually only our reactant lah, N2O4. Okay, apa tu? Jangan lupa dalam table kita, what we want is actually our equation. And then ada ice lah, initial change equilibrium. Since the information ni, so dia kata Kc kan, so kita akan guna yang concentration lah, which is M, capital M, molar. Okay, so for this case, kita tengok number, for the apa ni? For molarity of N2O4. Alright, from the question itself, dia bagi dekat sini, this is actually dia punya mole. So, we have to change it into molarity. So, kita kena carilah. Molarity is number of mole over volume. Okay, so from here, barulah kita boleh masukkan information ni in our initial. Okay, and then, so maknanya kalau kat sini, kalau product, if the information is not given to you, so again, product ni kita akan assume dia jadi zero lah, sebab at the start of the experiment, none of the product is being formed. Okay, so for the changes, ini dah akan jadi minus X, ini akan jadi plus 2X. So for equilibrium, we're just gonna combine these two. So, sekarang ni, okay, dia minta kita calculate the percentage of dissociation. So, dissociation ni mestilah change over initial times 100. Okay, and then it's actually for the reactant. Okay, change kita dah ada. Change pula. Initial kita dah ada. Okay, change we do not have any kan. Lepas tu dia tak bagi tahu pula in equilibrium. Dia hanya bagi KC sahaja. So, kita kena cari yang macam biasalah. From KC, kita akan cari kita punya X. Okay, so, before that, let's write down the KC for the equation. So, that is for X. Okay, usually where previously kita kena buatkan one by one dan cuba until lah last kali. Baru boleh kita ignore. Tapi kalau for the case of degree of dissociation, dia macam shortcut sikit. Kita terus pilih X must be a positive value. So, in this case, X is actually 8.066 to 1 exponent negative 3. So, dekat sini kita tulislah. From here, if you don't want to write X must be equal to positive value pun tak apa. Tapi kita tahulah X is equal to 8.06621 exponent negative 3. Okay, again, kenapa kita nak dalam kes ni sahaja X ni kita boleh terus ambil positif. Sebab yang ini kan change over initial kan. So, maknanya kita for these two value ni, for these two variable, we want it to be a positive value. Kita nak negatif lah. Nanti kita dapat negative percent pula. Dia tak nak. Walaupun degree of dissociation kita ni dapat negatif. So, kalau negatif tu sebenarnya dia dissociate ke tak? Dia form product ke tidak kan? Okay, so from here, so we know X ni is our change. So, dia minus ni bukan means that the value is negative. Dia minus ni maksud dia concentration ni akan berkurang sebanyak this value lah. Sebenarnya itu. So, this is our X. So, maknanya change kita ni is this value yang M. Okay, so make sure yang ini dalam kes ni memang kita punya Miss punya X my change, the changes for the reactant is minus X. Kalau dia jadi minus 2X, so kita kena 2 times benda ni lah. Tapi ini minus X. So bolehlah Miss terus ambil. The changes is actually, the change in concentration pun is this value. Okay, so kat sini copy. Okay, so sekarang ni boleh tak kita nak cari percentage of dissociation? So, sekarang ni change kita dah ada, is this value. Initial pun sudah ada. So, bolehlah terus cari. Sebab dekat sini dia bagi percentage. So, kenalah times 100. So, dekat sini kita guna degree of dissociation is actually change in. So, remember this concerning with our reactant. So, tulislah N2O4 any initial divide by concentration of N2O4 change pula. Ni, bukan initial. Okay. Change over initial. So, change dia sebab kalau initial tu maknanya value dia mestilah besar kan. Change not. Kalau change tak semestinya semua tu akan digunakan. So, that's why lah our initial tu, the big value will be our denominator. So, times lah 100. So, A kita change is this one. Initial is this one. Okay, so from here, we know that the percentage of dissociation is 12.5%. So, maknanya, before it achieve equilibrium, until it achieve equilibrium, hanya 12.5% sahaja of N2O4 is being used before it achieve equilibrium. Okay, so again, for the degree of dissociation ni, remember, only for our reactant, and X ni must be a positive value. So, make sure lah kira yang change ni, yang ini Miss boleh terus ambil X ni sebab my change itself is X. Kalau change dia 2X, kenalah times dengan kita punya value of X. Okay, so and the change ni will be smaller lah than the initial. Okay, so that's it for this video. Example 2, I believe you could try yourself.